Imagine you are drifting through the vast, silent void of deep space. In the distance, you see a terrifying yet beautiful sight, a massive circle of absolute darkness, bending the light of 1 billion stars around it. This is a black hole. But what lies beyond that shadow? Today we are traveling to the place where the laws of physics break down, the heart of a black hole. As we approach the black hole, the first boundary we cross is the event horizon. Think of this as the threshold of the black hole. Once you cross this line, escape becomes physically impossible. To get back out, you would need to travel faster than the speed of light. But since nothing in the universe is faster than light, you are officially trapped. To an outside observer, you would appear to slow down and freeze at the edge, turning redder and redder until you fade away. But for you, time continues to flow, though in a way we are only beginning to understand. The moment you cross the horizon, your body experiences one of the most extreme forces in nature, spaghettification. Because the gravity at your feet is millions of times stronger than the gravity at your head, your body is stretched thin, like a strand of spaghetti. It is a violent and strange transformation caused by the immense tidal forces of the black hole. At the very center of the black hole lies the Singularity. This is a point of infinite density where all the matter of a collapsed star has been crushed into an infinitely small space. Here, space and time as we know them cease to exist. Einstein's general relativity tells us the curvature of space-time becomes infinite here. Some scientists, like Stephen Hawking and Roger Penrose, spent their lives trying to solve the mystery of this point. Is it a dead end for matter, or a gateway to something else? Some theoretical physicists suggest that black holes might not be bottomless pits. One theory proposes the existence of white holes, the mathematical opposite of a black hole. While a black hole sucks everything in, a white hole would spit everything out in a different part of the universe. There is also the possibility of wormholes, Einstein-Rosen Bridges. If the singularity is not a point of destruction but a passage, black holes could be shortcuts through space and time, allowing us to travel to distant galaxies in the blink of an eye. Conclusion: black holes remain the universe's greatest unsolved puzzle. They represent both the end of everything we know and perhaps the beginning of a new understanding of reality. Solving the mystery of what is inside them could finally explain how our universe began. Until then, they remain the dark, silent guardians of the cosmos.